So, hello everyone. Hope you had a great break. And these are the homework that's due this week, and the homework that's due Thursday covers today's lecture. We're going to finish up logistic regression today. Now, there's also these conflict sign-up forms due on Long Kappa, and if you're in the online section, well, you can figure it out. Just go there and you'll see when your conflict is, and same with the in-person section. Just sign up and pretty much, even though there's lots of rules about who can sign up for finals, I'm ignoring them. So you can anybody who wants to sign up for a conflict final can. It's just too complicated right now. People are too stressed out, and I've got enough rooms. So this is not typical, not usual. And I know there's all these warnings, you're not supposed to do that, but I'm doing it anyway. So anybody who wants to can sign up for the conflict. But I bet most of you, if you're in the online, that means you can sign up for the Wednesday afternoon. If you're anyone else in any of the other 6 sections, that means your conflict is not very desirable. You can sign up for Friday the 20th in the afternoon in Follinger. So now, anybody who wants to, though, if you have some travel arrangement or really want to get going earlier, you can sign up to take it anytime during finals week using ProctorU. So I'm leaving that option open to people if you have plane tickets, but don't do it just for any reason. Online people can do it, but other people can do it too if they have pressing travel arrangements or you're really stressed out and want to take the final at a different time. You can do it on ProctorU. It costs some money though. Okay, and the last bonus is due, and the final just covers exam 3 material, so you should all study really hard because it's only covers 6 lectures. And it's you're going to be allowed the 90 minutes. The first 90 minutes and the second 90 minutes are for those who missed an exam. Yes?
So how many exams are left? 1 or 2?
There's just 1 exam left. It's called a final, but it's really exam 3. Okay? All right, so now let's get going. We're starting a little bit late, so I'll try not to dilly-dally. All right. So now what we're doing here is we're continuing logistic regression. And so far, what we've done is we've looked at we've just looked at 1x. We still have just 1x. But this time, and we always have, for all logistic regression, we have a y variable that's binary. So we always have a y that's binary. But the last example, we had a quantitative x. Now we're going to look at a binary x. So this is going to be a 0, 1. We're coding a 0, 1. We're going to do gender. X predicting a 0, 1, y. And this example, the 0, 1, y, is what? It's going to be whether we're continuing with our example of getting into med school or not. So it's acceptance or not acceptance, 0, 1, and we're predicting it by gender. This is an interesting, we're doing this because we want to know whether you're male or female gives you some kind of an advantage, if there's an advantage to being either male or female in applying to med school. All right, so that's what we're doing here. And so you probably, just to review a tiny bit before we jump into this after break, I just want to take you back to here where we had the 3 forms here of our logistic regression equation, and here we're doing with a quantitative y, getting in. The log odds is really nice because you have this nice linear equation. You have an intercept plus a slope. I'm just on the previous page 205 here. And you have this intercept plus a slope, and here's the biological science score. That has a really nice form, but it's very hard. It's not intuitive. So what do? Then we take the log odds and we change it to an odds form. Here, let me get a better picture of this. to this form. So this is a nice linear form, so we change it to the odds by exponentiating it. So this linear is now in the exponent. And that has a really nice interpretation because the odds ratio is just the multiplicative change in the odds for 1 unit increase in x. And then here's our probability form. Our probability form is just odds over 1 plus the odds. So that in some ways is the most intuitive. That's what we really want to get at. Okay? So that's our 3 forms. And so what we did was we looked at this and we let the computer do these estimates for us of the slopes. So we got this equation right here. And we saw that we interpreted the odds ratio as e to this slope, e to the 1.276 is the odds ratio. That's what we did last time. And we said this odds ratio of 3.58 is the multiplicative increase as you go from how it changes the odds of getting into med school for each additional biological science point. So maybe I should write this, show you, just because it comes up so often, let me just say, so what we're saying is when x increases by 1, then what happens to the odds? Well, then the odds, which are equal to, right here, e to the beta 0 plus beta 1x, there it's linear in the exponent, that is going to change to what? That is going to change to e to the beta naught plus beta 1, I'll call beta 1 x1 plus 1. Okay? So simplifying both of these, I could simplify this. Remember when you have a plus in the exponent here, that's the same thing as multiplying. So this is the same thing as that, right? So that's going to change to e to the beta naught plus, now this is a plus, so that changes to a times, that's a times, e to the beta 1 x1, and that's another plus, right? Multiply that out and you get another plus, so you get another times e to the beta 1. So you could see that right there is the odds ratio, e to the slope. It's the multiplicative increase, see, multiplicative increase in the odds for 1 unit increase in x. And in this case, it's 3.58. Now what we're going to do is, this was actually a real James Scholar project for a few people, and what they wanted to do, they actually wanted to see, they thought that females were being discriminated against, and they wanted to investigate this. So their next step was, okay, they said, that makes sense, and then they wanted to see if females were being discriminated against. So now we're going to the next page here, and to page 208, and now we're looking at, I want to show you how to interpret a binary x, not a biological science score, a binary x like gender, predicting y. So now we're trying to see, do males or females can you predict from whether somebody's male or female, whether they have a higher probability, a higher odds of getting into med school, all right? And so we coded, since there are only 2 sets of odds, as you go from, here, let me show you, as you go from x equals 0, that will be males, to x equals 1, that'll be females for gender, the odds ratio is just, there's just two sets of odds, so the odds ratio is just going to be their odds, their ratio. And it will be e to the slope again. So we let the computer, here, the 55 students who applied to the med school, that data set we've looked at again, and we want to know, we just use this simple logistic regression model, right, with the binary predictor variable gender. That's what we're doing differently. It's just a special case of what we've already done. And gender is coded 0 for males and 1 for females. And then we get this right here. This is what the computer gave us as, this is our intercept, beta 0, and this is beta 1. And gender is x1. All right, so that's what we've got. And so now, what's the log odds equation? We're just reading this. Just reading the printout. So we're saying the log odds, or the predicted, I'll put a little hat for predicted, the predicted log odds is equal to the intercept, beta 0, plus 0.8109 times x1, but x1 is gender. So that's all that says. So then what's the odds equation then? Well, then the odds equation, what do you want to do? You want to get rid of the log. So you have to raise to e both sides, so we get odds is equal, and it's predicted odds, is equal to e, and now this becomes the exponent up here. Negative 0.2231 plus 0.8109 times gender. Okay, and another way to write this is just e to the negative 0.2231, adding exponents like 10 to the 2 plus, raised to the 2 plus 3 is 10 to the 5th. That's 10 to the 2 times 10 to the 3. We're not doing anything. Some people have asking me about these exponent laws. Just think about replace, if you forget, just replace e with 10, and these with simple numbers. E to the times e to the 0.8109 gender. Okay, so those are two ways of writing it. And this gender right here is coded as 0 if you're a male and 1 if you're a female. That's what that is. Okay? So what are the odds of getting into med school for males? Well, if it's 0 there, the odds are just going to be that. We can do it. For males, we said G is equal to 0, so we just have the odds. The predicted odds is equal to e to the negative 0.2231 times e. Sorry, I'm writing this out so slowly, but e to the 0, anything to the 0 is 1. So that is what our odds are. Now, when you see negative, remember, this can't get, the odds can never be negative, but when it's less, when this exponent is negative, that means that your odds are less than 1, which means you're 1 to 1, which means your probability is less than 50%. And in this case, the odds are 0.8. E to the negative. If it's a positive, it's going to be greater than 1. If it's a negative, it will be less than 1 here. All right? But what's the probability now? Do you remember how to do that? The probability is, remember what I'm doing here, the probability is equal to the odds over 1 plus the odds. That's all I'm going to do. So your probability right here will be equal to 0.8 over 1.8, which is 44.444%. Repeating, 4.4. Okay? Less than 50%. Remember, negative exponent in the log odds. Remember, 0 for the log of 0 in the log odds is the same thing in the odds as 1-to-1, which is the same thing as 50.5 for probability. So here we have, for the guys, we have negative exponent here, which means that the odds is less than 1 and the probability is less than 50%. For females, it's going to be greater than 50%. So for females, we have G equals 1. So we have the odds is equal to what? I'm just going to put a 1 in there. So I have e to the negative 0.2231 times e to the 0.8109 times 1. Now you can see this is the odds ratio. As you go from 0 to 1, you're going to increase your odds. Here we had 0.8. We're going to multiply it by that odds ratio. The odds ratio is e to the slope, which is equal to e to the 0.8109, which is equal to 2.25. So I'm just going to multiply it by 2.25. Right? 2.25. Multiply it by e to the slope. You can see I just plugged in, as it goes from 0 to 1. That's all that happens. And so then I get 1.8, and that's just a coincidence that it's the denominator there. That doesn't usually happen. That's a complete coincidence. Okay? Either one. And so then the probability, you see what we have here? Here we have, now we get the odds are greater than 1, so the probability is greater than 50%. 1.8 over 2.8, which is equal to 64.29%. Any questions so far? So what can we say? Can we say, well, let's look. Is it significant? No, it's not significant, but we have a fairly small sample size. It looks like it's a pretty big difference. So if we had a bigger sample size, we might be able to detect it. But maybe it's not significant. Maybe it'll just go away if we control for other variables. Maybe females have this positive slope here because why? Maybe because they're better than guys. They have higher scores. Maybe that's why they're getting in. So our next step will be to add, and this is actually what we did, to add some controlling, make a multiple regression where we control for GPA, control for biological science scores, and then we expected to see the female advantage go away, and we even expected probably a male advantage, but we'll see what happens. All right, so far, let's interpret this. So compare the odds for females to the odds for males. Well, we're comparing the odds. We can do the odds of getting into med school are what? We just did it up here. 2.25 times higher for females than for males. That's e to the slope. That's how we got that. E to the 0.8109. All right, female odds equals 2.25 times the male odds. And you can see the odds ratio is just the ratio of their odds of females to males. And you can see these cancel out, and that's what you get. So what happens if we switch the gender? Let's think about what would happen. What do you think would happen if we switch the gender? Let's see. If we switched the coding, let's do it as an eye clicker. To what? females equal 0, and males equal 1. What do you think would happen? So think about that. I'm just saying, what do you think would happen to this if we coded it this way? So that will be the iClicker.
Oh, I forgot.
That's okay. Just tell me afterwards. Give me your number. Okay, so we'll start it. Okay, let's see. Sorry, I should have stopped this. Let me stop it now and see what you wrote. It should be what? C. Well, more people chose C. Let me show you. Let's just, first of all, let's go to the, here. Let's get out of here. And let's pull this up and see if that's true. First of all, maybe if you saw it, I could convince you. So let's go to pull this thing up, and you can analyze this data yourself. So let's just go to Stat 200. And I strongly encourage you to do this. Play around with this data set, or all data sets. And we just go to our data program. And this one, data analysis program, and this data set is in Stat 100 data sets, and you choose it, and it's called the Med Calculating Data. Where is it? MedCal, right here. And now we're going to go to Logistic Regression, and we're looking at acceptance as our Y variable, and there's two ways that I coded it. Gender, I coded it, okay, so gender, I just said, this is exactly what you see. Exactly what you see. Now, I switched the coding and I called it sex. It was just, I don't know, just switched it. And here you see it's exactly, it's negative. And that makes sense because if you think about it, let's go to the document camera here. If you think about it, the female odds are 2.25 times the male odds. So that would be the male odds, if you divide both sides by 2.25, would be 1 over 2.25 times the male odds, which means that it would be e to the negative. It would be the reciprocal of that, e to the negative, which would mean that this would be right here would be negative. This would be negative here, which would mean, because remember if you have a positive slope here, a positive odds here, that means your odds are greater than 0. That means your odds are greater than 1, and the probability is greater than 50% for who's ever coded higher as you go from 0 to 1. Okay? You get the log odds. Now, If you change it, it would just be a negative there. Okay? And then you'd interpret it as females, males would be 1. And so it would say when males is 1, as you go from 0 to 1, you get lower odds. You'd get e to the negative, which would be 1 over 2.25. Let's do that as an eye clicker. So let's go back to here, and we'll do an eye clicker. Here, we'll try, I think that's the next one. So let's get rid of this. And pull this out, and let's see, I think this is it. Yep. Okay. So hopefully this will help you see it. Okay, just a second more. Everybody should vote. Okay, I'm going to turn it off. And shoot, how did that happen? Well, y'all got it right now. I just started it up again. You know what the answer is, right? Come on, vote. Vote again. Oh my gosh. Changing depending on. Okay, I'm going to stop it. All right. Yes, it is A. I hope you knew that. I can't tell what you voted ahead of time, but let's just go and think. And if you knew the answer to the previous one was negative 0.8109. So now we know the answer to this one has to be e to that. Okay? Does everybody understand that? Any questions on that? All right, so let's go to the document camera, and you can write that down. If we switch the gender coding, then the gender slope would be negative. As we went from 0 to 1, males are being discriminated against, it looks like. But remember, maybe they're not being discriminated. Maybe females are just better qualified. That's what we're going to check next. All right. We have a lot to do, so I can't mess around too much more. All right. Does everybody have this down? Can I turn the page? All right. So now we're just going to go and compare this to a chi-square test. All right. So we have a 0, 1. We're just trying to see if males or females are favored. So isn't this similar to saying a chi-square test for independence is whether you get into med school or not, independent of your gender. Or it's similar to a two-sample z-test, is the percentage of people who got into, the percentage of females who got in versus the percentage of males who got in. In our sample, it was bigger, the percentage, but would it hold up? We could do a two-sample z-test. These are all the same. And so it's just another way of doing it. So regression with a binary predictor is almost equivalent to a chi-square independence test. So let's try it with the independence test, and you'll see how they're similar and how they're not. Okay, they're not exactly the same thing because logistic regression uses likelihood methods, but the odds ratios are going to be exactly the same, as you'll see. So let's just compute the odds for females, okay? So the odds for females, remember what odds are. Well, I tell you right here, but another way of thinking it is the number of successes over the number of failures. Let's look at what we're looking at here. It's probably hard to see what's going on. There were 55 people total. You see our numbers are small. 27 were males and 28 were females. Okay? Now, so what are the odds for females? The odds for females, we're just looking here for females. Here, for females, we're just looking there. So it's the number of successes is 18 over the number yeses over 10, and that's 1.8. That's exactly what we got before. I mean, if you want to do it as probability over 1 minus p, it's the same, remember? It's the same as p over 1 minus p, because the probability for a female getting in would be 18 out of the 28 who applied over the 10. 1 minus p would be 10 out of the 28, and those cancel out, so it's the same thing. Okay, now what about the odds for males? Let's do males. So males is these two numbers is what you want for the males. Okay, so the odds are going to be what? 12 successes versus 15 failures. And that is 0.8. So these two are the same. And the odds ratio is just going to be the ratio, because we coded females as 1 as you go from 0 to 1. So it'll be the odds for females over the odds for males, which is 2.25. Exactly what we got before. How does it compare to the odds ratio we got before? It's exactly the same, except for rounding error. So it should be exactly the same. What's not the same, the odds ratios are going to be the same. Remember, maximum likelihood methods maximize the likelihood of getting the data that you see, and this is the data we see. So it's going to be using these odds ratios, but it's so it's going to be exactly the same. But what's different is that this chi-square statistic is different, as you can see, from this one. This is our usual chi-square. This is really distributed as a chi-square, right? And these. But when we use these likelihood methods, we're getting a analog to the chi-square, an analogous statistic using this ANOVA deviance table, right? And ANOVA, I can show you. Let me just go to the PC again and escape. Okay, let's pull this down and pull that back up where we were. And let's look at our analysis, show the deviance table. Okay, so this is what I'm using right here, which in the limit, as n gets big, and you have more degrees of freedom too, but even as n gets big, in the limit it will be a chi-squared, but distributed as a chi-squared. What am I talking about? This right, where's our statistic? This right here, sum of squares model, isn't really a chi-square statistic. It's distributed as 1 in the limit, but it's very close, as you can see. So we're comparing this 13.83 and this is somewhat different. The odds ratios are exactly the same. and the odds. Okay, so let's go back to our document camera. And we can write this down. So this, we could say that was on the previous page right here. We didn't quite, here we go. Let's remember that. So this is 13.83 and 2.197. And here we have 13.96 and 2.183. So that's why not exactly the same. These are not exactly the same. Okay, but the odds ratios are. They're always exactly the same except for rounding. So finally, we finished 51. Now we're going to do chapter 52. Okay, so what are we going to do? We're just going to add multiple x's. We're going to add more predictor variables. Okay? And this part will be very, very similar. We should be able to go through this pretty quickly because it's exactly the same thing. The process of going from simple to multiple with logistic is just what we've done before. The coefficients in the multiple are different because they indicate the change controlling for the other variables. So here's what we got right here when we added biological science. The motivation for this was I was thinking that maybe the gender maybe would show discrimination, no discrimination for females, even discrimination for men, because I thought maybe females are more qualified, and that's why. So once we control for GPA, once we control for biological science score, once we control for everything, then we'll see that females don't have an advantage, they have a disadvantage, is what I believed. But I was shocked, because I looked at this, and all of a sudden I see the slope went up when I controlled for biological science. This is beta 1, this is beta 2. See, this went up. First, let's just look at the regression equation here. So notice how the slopes for each variable change. Okay, so this regression equation, I'm just copying this down here. See, we got a bigger slope. We actually have a bigger for both of them. Bigger for both of them than what we got before. So this is x1 and x2. Now, look at the equation. Who has the better chance of getting into med schools, males or females, given the same biological science score? You're comparing males and females that have the same exact biological science score. Who has the better chance? Females, because the gender Okay, what's the odds ratio for gender, and what does it mean? So this is pretty easy. The odds ratio is e to the slope. That's the odds ratio for gender, e to this slope. And this is 7.5 compared to what? Remember what we had before? We had e to the 0.8109, which was 2.25. Before we controlled. In the simple regression, now we have multiple regression. So what does it mean? It means what? It means that if you compare a male to a female with the same biological score, males to females who have the exact same biological score, okay, who have the same biological score, okay, so if you compare them who have the same biological science score, the female has what now? The female has a 7.5 0.5 times higher chance of getting in than the guy. Odds, not chance, higher odds of getting in. Than the males with the same score, compared to 2.25 before. So let's do a clicker on that. Why do you think that is? So let's go to the PC and we'll do a clicker on that. And let's just bring this up. Get rid of that. So sorry about this. It's very important call because of it concerns a family member so I'll take it later, but that's why I got distracted. Okay. So let's look at this. All right, so in the simple regression, the gender slope was this, but when we added biological science, the gender slope went up to that. What do you think that means? Thinking about, multiple regression, what does it mean? So just pick one of those. It means there's more of a difference now when you look at them at the same. I thought if females were more qualified, but now it turns out even if you look at them the same same level of qualifications, at least for biological science score, there's more gender discrimination. So what it means is, let's see if you got it right. We'll stop this, that they're negatively correlated, that the females actually have lower scores. Oh, you didn't get that. You said positively correlated. Oh, I probably didn't tell you. Well, gender, females won. So it means females are one. It's negatively correlated because we coded females as one. In other words, think of it logically. Look, if you think there's discrimination, right? You think that it's because I thought the females weren't getting in. I thought, if anything, they were being discriminated against. So I figured, they're just more qualified. Well, now it turns out, if you look at, pretend we picked controlled for everything. They're completely equally qualified. And if the gender slope goes up, that means they're really being favored. And when you take away those, if you ignore all the other things, it means that, males are doing so much better and everything else, so that it doesn't look like they're being discriminated. It doesn't look like the females are being favored as much. Do you see what I mean? Take it to the extreme. If they're getting in, let's say the females, I hate to say, I would never say this except I'm a female, and I feel like I can say it about, because I just want to look at the statistics. Let's say we put in everything. I haven't, but let's say we put in GPA, everything that we could think of, and the genders and the females get more and more and more favored. That means it has to be just the fact of them being female and nothing else, because that will be the only difference between them. So if it increases their likelihood of getting in, it means that they're discriminating against males and for females. Does that make sense to people? Does it? I'm not saying that's what happened. I haven't put everything else in. I didn't put GPA in. I'm just saying so far it looks like that. Okay? It's because females are doing worse. They had lower biological science scores. So when you ignore that, it lowers they're less likely, they're not as likely to be favored. All right. So this is the kind of thing that's really important you should be thinking about, because if you want to ever get to a question, like I don't want discrimination against anybody, right? But I want to be able to use statistics to figure out what's going on. Or maybe I believe there should be discrimination for females because I feel like they have a raw deal in so many other areas or something, and then I can say, okay, how much do I think they should be favored? But if we can't even understand the statistics and what's happening, then it's all guesswork, and what's the point? So that's why I think it's really important with anything that you're dealing with is to try to interpret it. Okay? So let's go back to the document camera. And so now let's do the same thing. What's the odds ratio for biological science score, and what does it mean? So the odds ratio, again, this is for the biological science, and this is the odds ratio for the gender. For the biological science, it's going to be e to its slope. So that's 1.66. And this is 5.26. So compared to what we got in the simple, which was e to the 1.276, which was 3.58 in the simple. So, it's been a while, but before, when they were all positively correlated, when we put them into the multiple regression, they were partial slopes. They went down because part of the effect of these was due to the other one. Well, here it's the opposite. These are negatively correlated. So now they're going to change, but they get bigger here. That's what you're seeing. They're bigger in the multiple when two variables are negatively correlated like that. It's a little confusing. Okay? And what does it mean? It means, what does this mean? What does this mean? It means that the odds, that if you're comparing two people, we're controlling for gender, comparing two people of the same gender, like two males or two females of the same gender, each additional point on the biological science score we'll multiply the odds by how much? We'll multiply the odds by 5.26, which is more than when you compared people of opposite genders. All right. So let's do some problems here. Let's see if we might be able to get to the last chapter, but probably not, which means I'm going to have to delay your homework because of all the technical difficulties we had. But let's do this part right here, and let's just look at this. And this we've already done before. So here, we're going to use this log odds equation. And remember, we could use the odds ratio for gender was e to the 2.015, which is 7.5, and the odds ratio for the biological science score was e to the 1.66, which is 5.26, and we're going to go the whole hour this time because we had so many delays in the beginning. All right, so now you can see, first you get the log odds, then you exponentiate it, and then you get the probability. So we're just going to do the same thing here. All right, so for females, what is the difference? Males are coded as 0. These are coded as, okay? So for gender, we're going to we put a 0 in here. So now we get negative 17 plus 2.015 times 1 plus 1.66 times 10. So we're just adding 2.015 to that. Okay? That's all we're doing. and we get 1.615. All right, and then we're going to exponentiate that. And we get 5.028. This is the same thing as multiplying by what? The odds ratio for gender. So here, this is the same as, you could have done 0.67 times 7.5, and you should get the same thing within rounding error. Either way, that's all we're doing. And now, this part is easy. It's 5.028 over 6.028, and then we get 83.4%. Now, that's the difference between males and females who have the same biological science score. Here's their probability. But remember, that's going to change depending on where we are in the curve. So you have to go through all this. All right, we can just do one more here. What if it was a male who had a score of 11? Well, what would change here? This would just be negative 17 plus 1.66 times 11. So we'd just be adding 1.66 to negative 0.4, and we get 1.26. So now his odds, his log odds, are positive. That means his odds are going to be greater than 1. We could have done this. We could have just multiplied. It's a 1 increase. So we could have 1 unit increase in the biological science score. So we could have taken the 0.67. We go from here to here and multiplied by the odds ratio by 5.26, and we would have gotten the same thing. All right, so now we have 3.53 over 4.53, and he has a 78% chance. If he went down 1, he'd have even more negative here. I'm just going to give you the answers, and you can make sure you can get them yourself. 1.27 and 11.3%. All right. Now, a female has a biological science score 2 points lower than a male. How do the odds of getting into med school compare? We're going to have to use those odds ratios. All right? So for being a female, she's going to get what? An odds ratio of e to the 2.015. 7.5 times the odds just for being a female, okay? But now she has 2 points lower. So here's for each point lower, you'd multiply by e. If you were higher, e to the 1.66, but if you're lower, e to the negative 1.66. This is for being female, right here. This is for being female. This is for what? The first point lower. And then you're going to have to do it again for the second point lower. By the way, this is the same thing as, you could see it's the same thing as here's for being a female. And instead of multiplying, we'd be dividing by this. That's the same thing. When you put a negative there, it's the same thing as, so that's the same thing. And what we got when we did all this is e to the negative 1.305, right? It's going to be more negative. You add those two together, we're going to get something negative here. So that means her odds are lower. So for 1 point, her odds are higher, but if you're comparing her to a guy with 2 points higher, her odds are lower. Okay? These outweigh that, because 1.66 plus 1.66, the negatives are greater than the positive. Okay, now the odds of a female getting into med school are the same as the odds when? How would you do that? why don't you just go back to the log odds equation, all right, and say, okay, they both have the same log odds equation. So for females, it's negative 17 plus 2 point, I'm just going back here. Okay, they have a 1 there. So 2.15 times 1. So this is females. Plus 1.66 times the biological science for females. We want that to equal, for males, it's exactly the same, except for gender, we're putting in a 0. And we're trying, oh, shoot. Okay, so for gender, does that look like it did before? Sort of? Good enough for the last 5 minutes? Okay, so here we're going to say plus. We want to know what scores. What score? So biological science for the male. Okay? We want to know how they're going to compare. Okay? That's 0. So now negative 17, we can add 17 to both sides and simplify, and we get what? 2.015 equals bring that over to the other side, 1.66 times the biological science males minus the biological science females. We'll divide both sides by that. And that is their difference. 1.214 is equal to the difference between the two scores. The males, when the male has a score that's 1.214 higher, if it was a continuous variable, they would be the same. So when a female has a score 1.214 lower,